Hello everyone, my name's Gary, this is Small Scale Big Dreams, and today we're going to continue talking about 9F and the work we've been doing on her. Roll the intro. Okay, well, welcome back. More 9F. So I have a 5-inch gauge live steam 9F locomotive, which was originally a Winston kit. Earlier this year I've had some issues with it. We're still having some issues with it. We have managed to get her in steam, we have managed to get her back on air. However, there's some issues around the valves still, and we're going to go into that. I've had to do some more work on the lubrication system, which is all brand new to this engine that I've recently updated. I'd like to take you through some of them steps, and then we need to talk about combination levers, valve gears, and everything else. So first off, we'll start here on the bench with some drawings, and then we're going to go over to the loco, and I'll show you what I've been doing, and then what's next in the plan. Okay, let's go. Okay, so let's start looking at what we've done with the lubricators then. So we've had the engine running on air, and we've had it in steam as well, all on the running board, all on the rolling roads, and we'll take you through sort of some of the things we found out about that. The first thing is the lubricators initially didn't seem to really be turning, so you get like 60 revolutions of the wheels before the sort of ratchet went round once, which is just, yeah, it's just so minute. That's really far too little. It just doesn't fill me with confidence that's enough oil for what we're trying to do. So basically, what happens is this lever here is not on my system, but I'll take you over to the loco and show you it all. As this moves backwards and forwards, it basically on a little ratchet. There's a little ratchet ring in there, and then there's one, in here as well. So they can move back and forwards, and it causes this wheel to turn. The arm comes down, pushes on this plunger, and then all this is assembled in here in this little oil pot. So you put the oil in the top here. And it pushes the oil down, and it creates like so every time, and then it springs back up. Every time it goes down, it pushes a bit more oil into the lower gallery, which again is like it's a 90-degree joint on my engine, and it runs off up here into a non-return valve, and then the valve and cylinders over here somewhere. So yeah, so what I've had to do is I had to modify the linkages. So this obviously we don't use these because these just look awful. So I've made up my own set, and we talked about them in previous videos, but I'll show them again now. But I basically had to make it so the arm is a lot shorter here, so you get more number of movements for the same rotation of the wheels, because you've only got so much drive. You kind of got to use it as much as you can. So this arm is a lot shorter. It's about half the length it was. And again, I'll show you on the engine what it looks like. It doesn't look too bad, actually. It's not really what I wanted to have. But at the end of the day, it's got to pump oil in, especially all the problems we've had. And there's a few things to talk about. But I'll stick with the oil for now. So there's a little spacer on this diagram here, which is number 15. So we just go down here, oil spacer. So I'd put the smaller ones in initially, just because then I didn't have to modify anything. There are instructions with this, so you can put a slightly thicker spacer in, and it does recommend it for 5-inch gauge. I'm guessing it's thinking of a single 5-inch gauge loco, so one lubricator for 2 cylinders, which is what this engine had. I've got one per cylinder now, so I was like, I didn't want too much. Completely changed my mind on that. Oil is cheaper than engineering by a long stretch, so I've decided, right, we'll put the thicker spacer in here. We've done all that. They've all been off again, back on the engine, and again, I'll show you that. But I've also modified, it's not on this diagram, this drawing here, but there's 2 inlet holes at the base of this, what they call a lubrication nipple. So that allows the oil to sit in a gallery. So as this comes round and pushes down, it forces the oil down through here, and off into the gallery, and off to the engine and the cylinders and the valves, etc. I've just opened them up a touch. They were pretty small. I can't even think what size they were. But I've just opened them up, so there's always opportunity for the oil to get in there for the plunger to push it down. So we've done all that, and again, I'll explain that a little bit more when I go and see when we go over and see the engine. So that was the first thing. Let me just move me things around. So I'll talk about oil in a moment. Valves. So valves. And I just seem to be talking about valves a lot. We are having some issues. So, just so we're fully aware, these are the Les Warnock drawings for the 9F. They're as best I can get. From what I can understand, there was some basic isometric assembly drawings for Winson for the 9F and their other kits. There's no dimensional drawings. I believe some had CAD files for things, but getting hold of them is a real challenge. Anyway, after the air runs and the steam tests, and again, I'll put footage in this video, we'll bring you right up to date, because we have found a few other things and we've kind of made some discoveries and this, that and the other. I've decided I've taken all the valves out. I had one side out and we did the rework. In fact, I've got the rework valve in front of me there. So there's the piston valve I've made on the lathe with the piston rings in, and that seems to have worked okay. I have made some improvements to these, and I'm going to talk about them right now. Or I'm going to be making those improvements. We'll talk about them now. And then I'll go over to the bench and I'll probably show you. Again, I'll have the valves out in front of us, the ones that were in there. The more I've kind of dug, the more I've found. Might be worth at this stage as well, just mentioning this book. So this is D.L. Ashton. I bought it a couple of maybe about a month ago now, and this is what I'm looking at: Walshart's valve gear. Now there's a Stevenson valve gear as well in here, which is on the Manor, which yes, that still exists. Yes, I haven't done anything to it because of all the issues with the 9F, but there's still a fair bit to go. And this basically tells you how to set up Walshart's valve gear. And one of the kind of key points I'm getting that isn't on my engine or wasn't is these kind of dimensions here. So A is basically the entire length of your valve bobbin. So there you go. There's that one. Now on my engine, I think it's 2.066 inches. So it's like just over 2 inches. Let's call it 2 inches for the sake of this video. 2 inches long. Okay. And that sits just covering each end of these two ports here. So you've also got lap and lead and everything else, but I think that'll save for an extra video. I want to go through this in kind of a structured way and sort of show you kind of more how I'm approaching getting my valve gear set up, what impact that has on lap and lead, and it'll come a bit more important when, further on in this video when we talk about the combination levers. So yeah, been doing lots and lots of research on valve gear, especially Walshart's valve gear, obviously, looking at my engine, looking at the information in the book like this. Now, this is quite an in-depth read, as you can see. Everybody loves an equation, so there's plenty of them in there. There's some quite interesting diagrams. I can't remember the names of them, but they're all in here. And yeah, there's a lot to think about with this. But really, the main thing at the moment for me is I need to make my valves. I've got piston valves like this. This is a key, so that's B is port width and lap. C is between the two bobbin heads, and then A is the full width across. Just going back to this design drawing here because it's much easier to sort of point and show. As you can see on the Les Warnock drawings here is valve. So there's his valve bobbin, there's the spindle, and he's basically got two heads. Both cast iron. One's, he said, you can have rings on them or you can have oil grooves. I'm going to go for rings on mine. I've got all the piston rings in stock now. And then he's basically made two cast iron heads, and then there's a single spindle. Now I've made my other one, so this one slightly different. So this more reflects. I'll just pull them in front of here, but we're going to talk about these a bit more anyway. The design that was in there. What I've discovered is my valves are different sizes from, over ports here is a 3/16 of a ports. On mine, there's two different sizes for a start. And again, I'll show you a bit more on that on the bench. I'm going to go for this dimension, not the 3/16, but the over the ports. I can't seem to find a drawing of any piston valve where there is elongated piston heads over the ports. I think that's known as exhaust lap. So you'd have an extra, the piston head would be extra here, and it'd be extra here. I've never seen a drawing of it, and from reading through Don Ashton's book here, he mentions it, but he doesn't really go into it in any detail. There doesn't seem to be any need for it. So I guess we're going to be some experimenting. It's now cold October time. I've got a fair bit of time to go. I mean, the engine's out of steam test now, and it would need a new steam ticket to take it running anyway, even though it's currently in bits anyway. So I think I'm going to do some experimentation. Now I'm happy with the lubrication system. I think I'm going to try these valves. Probably, again, what I'll probably do is bring this back in. An updated version of this. So this would be 2 inches long. The lap and the lead, that's still to be decided. And again, we'll talk about a combination lever in a minute and the issues I've got with that. Probably getting this down to a minimum so there's more sort of steam chest valve pressure. This is, apologies, I've forgotten your name. Someone did mention this before, and yet you've got a very good point. There's quite a bit of meat on that. We could probably make it a bit thinner. I'll use the same valve rods. Here, this bit here, the finger there, and the fingers there. But get rid of, we're definitely not having this 3-component loose wobbly nonsense. That's all going. I think I mentioned on the last video, actually, this is where the air, I did a sort of pressure air test on this to see if the valves were leaking by, which they were massively. But they're also leaking through the middles because there's a great big gap with this random bit of whatever it is in the middle. So we're going to get rid of all that. Not using these dimensions because these are for a completely different engine. Well, it's for a 9F in 5-inch gauge, but they're not for my engine. All my valve gear is slightly different size on the Winstons. Just to give you an idea, look, there's a combination lever, and again, we'll talk about that in a moment. These dimensions are useless to me, but the idea is sound. I don't need a great big thick piston valve through here, taking up this space. This is your chamber. This is your steam chamber here. This is where the steam comes in. It comes in here, and you basically, as the valve moves, it moves into the piston cylinder itself, pushes the piston back. It exhausts out that way, and again, this valve moves back and forwards. For the valve gear. So we're going to try that. So that's one thing to look at. Excuse me a second while we move drawings around. It's very handy having less one at drawings. The next issue is we have found a problem. This is a combination lever for the 9F, which is, put it down. That's mine. That has been straightened. However, it was very badly bent. I will put up some pictures in the corner here now to show you. Again, all these dimensions are irrelevant to my engine. These are all designed for the Les Warner drawings, and in fact, if you come, just move this up a bit, there should be some data. Where is it? Get that out of the way. Is it on the other side? There we go. So essentially, this data here tells you your lap, your lead, your max full gear cutoff, full gear valve travel. This is something I need to figure out on mine. According to Don Ashton's book, that's quite an excessive amount of valve travel. But let's see what it's doing. I've seen these engines running. If they're built to these designs, it seems they are particularly good. So I've got no reason to doubt any of that's right. But I don't have that data for my engine, so I've got to figure some things out. On the test, it quickly became apparent, and again, I'll put some video footage up of the engine in steam, and I've got some on the left-hand side and on the right-hand side. This was bent. This is a combination lever. It's one of the key parts to the valve gear. Let me just show you where it is on there. There you go. Look, that's the combination lever here. Look. Essentially, mine is bent here, bent off at an angle, and you'll be able to see it. I'll try and sort of point it out when it on the videos. So essentially, these dimensions were all wrong. Now, I've straightened this up a lot. I've spent a fair bit of time on this, and now I've managed to get all 3 holes the same. I'm still considering making brand new ones to the original side. So this is the right-hand side. I think this is the one that was bent, and perhaps you can tell. it's been straightened out a fair bit, but it's taken a bit of a toll. And to be honest, they're a little bit homemade anyway. There is an argument to have completely new ones set to these dimensions, I guess. But there's a bit more investigation to go. What I really wanted was a Winson combination lever that someone has somewhere, and if you've got one, I'd be interested in buying it from you, that's not been bent or kicked around or whatever, and get the dimensions back. Because at the moment, I'm kind of having to guess, which is never really the way you want to go. That you want to know what's going on. You know, like these designs, these drawings, this information. It's all built off this system. But at the moment, that's my option, and we're in kind of sort of iteration design mode with it anyway. We're not going to cause any problems to the engine. We need some valve travel, but they need to be equal both sides. So I'll fabricate 2 new ones of these. I'll try and get the best dimensions I can off of this. If anyone has got one, I'd be very interested to know what the dimensions are. Just message me on the channel here. I'll link into one of the model engineering or sort of sites that I go on. Big shout out to Noel Shelley, who's on there, who contacted me about his tender, and I will actually get round to replying to you. I will get a chance to measure it. Yeah, this is a headache. So that's what we found. We've had the engine running, steam, and on air, or on air and on steam, makes more sense. But yeah, I at least know I can make a valve bobbin that works. So there's a valve bobbin that I made that was on the steam test you're going to see in the footage. They're the other 2. I think we'll go onto the bench and talk about these all together, because I want to talk around the engine as well. So we'll go and do that now. Right, and here she is again. We'll do a bit more of an exploded out view. We seem to cram ourselves into the darkest corners of my workshop every time I come to sort of do an update. So we'll start as we did on the bench. We'll talk about the lubrication system. If you go back and see some of the other videos on the channel, and there are getting quite a few now. Basically, this is the operating arm I'm talking about. So that there is the sort of manual prime. That's where you put your oil in the top. Not the best angle, but this is your actuating lever and arm, and this is all stuff I've made up in the workshop. And actually, as you can see, we've got a fair bit of the motion removed. There's the little 90-degree T-piece, and the pipe goes up into a non-return valve and in there. And basically, you should pump oil into the top of there through the steam inlet. That oil with the steam will pass around the cylinders and the valves and keep everything nicely lubricated. I say all this has been off. The other side is an exact mirror, so it's exactly the same on the other side. Took them both off, updated the spacers, and I've cut these down to about half. The original ones are still up there. I just made new ones actually, and it seems to work a lot better. We tested it in this configuration in Steam. You get a fair few more revolutions, or faster revolutions, and we should get plenty more oil now. As I say, I've decided to go. Oil is a lot cheaper than ripping out valves and doing all this kind of stuff. But yeah, hopefully that should give a nice positive flow. As I say, there's 1 per side now. Yeah, so hopefully that'll be all okay. As you can see as well, so the valves are out. I haven't taken the pistons out yet. I probably will do that over the winter, but at the moment I'm trying to limit the amount of bits I've got in pieces. This side, the valves had never been out before. I'd had the other side out, and that had my new valve I'd made, and I've shown you that a few times in this video already, but we'll go on the bench and I'll show you it all. And again, this side, the left-hand side, because as you sit driving, facing forward, this is the left-hand side on the engine. Seems to be pretty okay. It's the right-hand side that seems to have the issue. The main one being the combination lever is clearly bent, and you'll have seen on the footage of the loco ring on air. So I had it in steam for easily an hour, continuously running, not just in steam sat, but running for an hour. It sounds offbeat, but fully understandably, given what I now know about the combination lever. Had I known that before, I wouldn't have steamed it, I'd have replaced it. As I say, I'd really like to know what the Winson dimensions were, but there just aren't any drawings, and no one seemed to have any idea. No one seems to have access to any of the original card or anything. So I'll have to do my best or come up with some kind of solution. It might end up being that basically all of this needs to be fully measured up, all gone through. The return crank position, which on this engine is a particular pain because they're already preset. And if I can just bring it down a touch, just to explain. So here, my return crank, you might just see it is basically pinned in this position here. To change that would be basically the wheel set out, I think, to do it properly anyway. You might get away with it perhaps, but I'm kind of loath to do that. And maybe that's the kind of problem you come across with these things. How deep do you run in? How deep do you go? So, for now, we're going to have new valves to the sort of Les Warnett theory, well, the Les Warnett sort of structured design, in that you'll have a very fine bobbin with heads, lap, lead, all that stuff. I'll have to calculate. I'll have to work that out. I'm going to have to work out some of these things. Two new, probably brand new combination levers. I might see if these two straighten out, and if I can get them both pinned together. I have had that. We'll see. It's just there's some issues with how that's going to work. So yeah. So we're going to leave the pistons in for now. The valves are out both sides. We'll go and have a little look on the bench, and then we'll come back for kind of a wrap up. Happy days. Okay, let's give this a go. Actually get to see the engine, which is probably what you've really come to see. Yeah, so combination levers. These are the combination levers shown to you on the drawing earlier in the video. One of them, this one, is the left-hand side one and the engine. So this side you can actually see here. It's all a bit reversed because of the camera. That was fine. There didn't seem to be any issues. When you see it on the video, you can see the valve travels pretty good. So I'm pretty confident that's probably okay. It has had a hole ream through it. However, it is as drawn. This one on the other side was bent. And I'll put some pictures up. But basically, these three holes are kind of key to your entire to your motion. So there's three holes. There's the base one. And you've got, this hole here is where the crosshead goes through. So if I can just go in my box of bits, I'll show you an horrendous crosshead. There we go. This bit in the top, it's got like two little brass things. It's rubbish, and I think I'll make new ones eventually, if not as part of all this bit. But essentially, these two centres here should be your lap and your lead for your valve. So with this bent, and it has bent literally across the top here, just come in a fair bit, look. These two holes, basically it was an angle. I got a reasonable picture and I'll show you. And in fact, you can probably still see how bent that is or was compared to that one. Try and hold them together. Yeah, still shaking, I'm afraid. So when I found that, I mean, it kind of makes sense. So when we was at Gilling, the right-hand side of the engine was the one that was causing the problems. It was the one blowing through. It sounded like a traction engine. It was clearly only running on one cylinder. Anyway, we got it all back and dug all the valves out. We'll talk about those in a second. I'll carry that on. Yeah, and that would be why. That would be a big part of it. I don't think it's the only problem, as I've found as I've looked into the engine, and I've always kind of known she's run okay. You can see on the videos on the channel, she's ran pretty well. Not perfect, and everyone said, yeah, it sounds all right. It's not quite right, but it sounds all right, and it seems to have a bit of pull. It was fine for what it was, and I did. I've loved driving it and everything. And one day I'd like to get back to doing that. But yeah, so there is a problem. We can solve it. I've ordered some material, so I'll probably make two new ones. Really, these are okay. Bits of metal, bits of metal. It's the dimensions that matter, and I'd rather have two to the good one than 1.5, or they're going to have to be a matching pair. They have to be exactly the same. It's very clear in Don's book that I showed you earlier. These two holes decide are the same as your lap and lead at a set position in the valve motion travel. And if this is basically bent backwards, you're not getting that extra valve travel, which is why the pistons aren't allowing steam in or out in the right way, which is why on videos you'll have seen it sounds offbeat, because it is, because it can't physically throw the valve far enough. So there is that. So happily we've come up with a solution for that. Let me just make sure I get these in the right pot. That's left hand, that's right hand. Yes, they're all marked up pots. The other thing is, okay, so we took all the valves out this time, and I am going to hold the rear face of these valves together. I don't want you to tell me what's wrong. I don't know if you can see that. This valve is clearly longer than this one. Never seen anything like it. I can't find anyone who would say, well, oh, it needs to be that because of that. Is that because of the valve throw? Would you machine piston valves? I mean, you can see it. So if I pulled that up there, see the internal insert again, this weird 3. If I hold that one with that one, look at the difference there. Now I've had these apart and put them back together as they are. So if I just bottom them out there, look, that's the actual. Let's see if I can do this with it. Apologies. There you go. Look, that's the difference in valve length. There, just there. Clearly, it's massive compared to this one. Why? Don't know. Garbage. We'll get rid of them. They can all go in the bin. The valve spindle themselves seem to be fine. They're just a 2BA thread on a spindle. I'll make new valve bobbins to a much finer design than that. I mean, these are quite weighty, which is, I don't know if that's an advantage or not. But this was my first go at one. I've never made a piston valve before. It's not the kind of thing you make every day. I've got a lathe set up now. When I made this one, I think I had a slight angle. So basically, one head is slightly smaller than the other. Now, I did lap them in, but I think, yeah, I've slightly machined like a very fine taper onto it. So this side is smaller than this side. Now, these are the new rings as well. I've got another set of rings for this side. I've realigned the machine to centers again. I've had to adjust my tailstock a little bit. Maybe it's just got knocked or something. But yeah, so I'm pretty confident I can make 2 solid ones of those. I was thinking about making 4 individual heads and making new valve rods, similar to what I've just shown you on the design. But I'm not going to do that. But I am going to use the sort of the 2-inch, roughly 2-inch across the ports, and I've been trying to measure the ports as accurately as I can. So the ports, I don't know if you can see, you won't be able to see, but basically the actual ports are actually in the valve. So trying to get at them, it's not like you can get a set of digital calipers in there or anything like that. I've had to kind of jiggery pokery set up. I think I've got them pretty accurate now, and so it's just a smidge over 2 inches, and they're both exactly the same. So why would someone make 2? I don't know. Maybe they're trying to compensate for something. Maybe it's the fact that combination lever is being bent and is bending over years, and then maybe that's been kind of the main problem. Don't know. So yeah, lubricators. I think we're on the home stretch of the lubricators now. They're back in. They're all assembled. They seem to pump a fair bit of oil now. They've had the bigger spaces fitted, so I'm pleased with that. I've had the engine on steam. What it really proved to me was I could make a valve bobbin that would work under steam. Working in air is one thing, and I think I mentioned this on the last video. But having it run on steam proved that actually I'd made that okay. And did it run all right? Yeah. I'm pretty not picky, but she has to sound right. She has to work right. This engine's got some work to do. Pulling me around, I'm not small. It should pull adults, 5, 6, 7 adults relatively easily. It should do all the things I want it to do. And I just don't think that's the way to do it. So there we are. So yeah, lubricators, happy with. Combination levers, I've got one I think's okay. I'll have to use those dimensions and they'll have to go back together. I'll machine new ones up. And obviously the new valves, again, probably a more refined design than this one. Probably sort of take the OD down in the centres, proper lap these in, and as I say, I've reset the lathe so we can actually cut parallel across the heads, and then I basically lap them in. I have some really fine emeries and stuff, and I basically, as I tried to push them through the valve openings, just lapped them until they went in a tiny little resistance, not much, and then I put the rings on and everything, and just settled them in as well. So I've got all the dimensions I need in this. Just got to make one of the heads a little better. The other one was very good. Yeah, so, and then we guess gonna have to test it all out again. Yeah, it's going to be a long winter, I guess. There's a lot to think about. There's a lot to do. I still enjoy it, weirdly. I still really enjoy what I'm doing. I can't get over the fact that I own a 5-inch gauge 9F. She ran very, very, very well. Really pleased with her. There's a load of other bits and pieces as well. So there's all these kind of connections into the tender and stuff. I've got a little bit of a hit list. I made a snagging list. The engine when she was in steam, testing it out. The injectors and everything seemed to work okay. I've got a bit of packing to do on the steam valves for each of those. They're blowing by a bit. She did have quite a bit of power, which was nice to see. Probably a lot more than she's had for a long time. So yeah, I'm hoping with these refinements, do these works, get each side sort of as even as we can, and again work through any other issues. Yeah, so there we go. I hope you've enjoyed that. It's a bit of a long one, this one, I think. I say I had the engine in steam for over an hour. We've done several air tests. I think it's up to about 1.5 minutes, 2 minutes on air. The compressor we had was very, very small, so I'm quite surprised. But yeah, it's there's more to do. It's still enjoying it mostly. It keeps me busy at night. I've learned a lot more about valves and valve travel and sort of washing out valve gear since the last time I did a video. So yeah, right, wrap up time, I think. Right, well, welcome to the last of you who are still watching the video. It means a real lot to me that people watch these videos. I'm really, really pleased with the amount of subscribers we got. So the last video, I think we got about another 60 odd subscribers out of it. We're nearly at 800. I'd love to make 1,000. That'd be really magic. And it's just lovely to know that people out there are interested in this kind of stuff. It's a very weird hobby in some ways, but if you have the bug for steam, it's unshakable. I wouldn't want to be without it. My family think maybe I'm a little bit odd, and you know, I don't know really, but yeah, it's just such a massive learning curve all the time. But all that sort of learning you can pass on to the next engine, or if someone else has that issue, you can try and support them. Yeah, you get a lot of pipe puffers out there who will tell you everything that's wrong with your engine before you even put fire in it and all that stuff. Don't worry about them too much. They probably have been through all this stuff before, and that was the problem with their engine. It might be completely different for you. My view on all that is, I really enjoy the hobby. I love it. I used to do standard gauge, and I really loved that as well. Steam engines are just my thing. I'm just wired in that way. You get, they say, a lot of people who kind of want to tell you how to do everything. You've got to learn this stuff for yourself sometimes, and that's kind of what I've done here. I've had to go away and research it. No one has this engine anywhere else. All right, you can have a Winson 5-inch gauge locomotive 9F class. You can have a Les Warnock one. This one's had people in here doing work in the past. Some of it's fantastic. Some of it, like the piston valves, who knows? So you've got to figure this sort of stuff out for yourself sometimes. You've got to learn these things. And I find that really rewarding. I always did on the big ones. 5-inch gauge is even better because I'm in my workshop here at home. It's a lot. You know, I've got the machine tools. I don't have to have 10-foot lathes or anything stupid like that. It's really great. But yeah, so, you know, please do like, share and subscribe. If this is what you're into, stick around. I know the videos are a bit few and far between. Hopefully you can see I've been actually building up all these things to bring to you now in this video. There would have been another one out recently of a day trip. This is the kind of format for the winter, I guess, because I'm not really going to get it anywhere. Well, maybe not. We'll see. We'll see how things go. I've got some spare time to take, so it might be an opportunity to get on the lathe, get the valves made, make new combination levers. We'll see how we get on. But yeah, thank you ever so much for watching. Love it. It's brilliant. We'll catch you all in the next one. Thank you.